Hello, ladies and gentlemen, and welcome to today's webinar, 5G Use Cases for IoT, sponsored by Sierra Wireless. Thanks to all of you out there who are listening and joining. I am Ken Briota, the Editorial Director for IoT Evolution, and your host for today. We're going to be looking at a huge variety of things today, starting with our little agenda here. We're going to be doing 5G 101 for IoT. We're going to be starting there, looking through some of the things you need to know about 5G. Then we're going to look at 3 use cases, which will drive the 5G revolution. And then finally, we're going to look at the technologies that are making 5G and the relationship between 5G and LTE happen. But before we do any of that, we want your opinions and your thoughts on some of the 5G issues. So we're going to do a little poll here. And we'd like to know where all of you folks listening are on your IoT journey. Sort of where you're sitting right now as you walk into this webinar, or I suppose sit in this webinar. Right now, are you connecting your products with cellular technology? Are you connecting your products with non-cellular wireless technology? Or using Wi-Fi, Bluetooth, or Zigbee, or are you still researching the best way to connect your products, sort of the advanced, intermediate, and beginner levels primarily. So go ahead and click those radio buttons and hit submit as you're going through the poll. Don't forget to scroll down. The submit is below the scroll there. Choose your options, and we'll go to your results in just a moment. While we're doing that, I want to introduce our main speakers, Gus Voss and Jim Engelson of Sierra Wireless. Gentlemen, welcome.
Good morning, good afternoon, everybody, and thank you for joining and taking the time today.
Yeah, thanks a lot.
As we're getting some of our folks out there to answer our poll, remember, folks, you are voting right now if you just joined us on where you are in your IoT journey. You'll see the poll questions on your screen right now. Just click the radio button and hit submit to put your answers in. Gus and Jim, starting with you, Gus, why don't you tell us just a little bit about yourself before we get right into these answers?
Sure, yeah. I'm a chief engineer here at Sierra Wireless. I work in the CTO team here, and a big part of my job is to attend cellular standards groups, in particular 3GPP, which is the standards group that is defining the 5G specification.
That's great, Gus. Thanks. And what about you, Jim?
And for myself, I'm part of our product management department. And currently, 5G is a large part of our next generation roadmap offering. So I'm very keen to speak about 5G today and get everybody's feedback and questions afterward.
All right. And speaking of that, well, wonderfully segued, Jim. We're going to go to the answers in our poll right now. Let's see what everybody was thinking. Where are you all in your IoT journey? Wow, we've got a lot of folks. Just over 45% of our listeners are already connecting products with cellular technology today. So that's really interesting. Almost 15% are connecting products with non-cellular wireless technology. About the same amount, nearly 15%, are still researching the best way to connect products, and nearly a quarter are just here to learn and find out more, and are not currently connecting products or aren't really in that cycle right now. So I'm going to hand this off to Gus and Jim to get us started. The microphone is yours, gentlemen.
All right. This is Jim Engelson, and I'd like to kick off the presentation just kind of talking a little bit about the use cases we see around 5G and some of the timelines for those. But so we're here to talk about 5G, but I just wanted to take a moment to review how we got here. And going back to the emergence of 2G in the early 90s, it's interesting to see how new generations of technologies tend to emerge, every 10 years or so. And we're seeing that cycle continue with 5G today. I think it's important to note that with the emergence of a new technology, that doesn't mean the old ones go away. For instance, we still see 2G being shipped or deployed in various regions of the world today, similar with 3G. So, this is 20, 30 years after the fact. And, one of the key points here is that even if a new technology emerges, the old ones coexist with that, so they don't go away. Another thing this chart highlights is that when a new technology does come along, we do tend to see a rise in data throughput speeds. And what's interesting to note is you can see that continues along through to LTE, but at that point we do see a branch into two separate paths. One being the continuation of that high-speed mobile broadband path, along with a lower branch speed, down to LTE-M and NB-IoT, which we see addressing the growing demand for the low-cost IoT and LPWA markets that are really burgeoning today. And as you can see, both these branches will then continue on into 5G, and we'll touch on both these paths as we get along into the presentation. Just getting back to an earlier point that I touched on regarding longevity, I do want to highlight that although there's a tremendous amount of buzz about 5G right now, it's still okay to deploy on LTE today. The technology itself will be around for some time, and in fact, the initial 5G rollouts we're seeing today are actually all based off of LTE technology. And Gus is going to talk more about coexistence with LTE and 5G in his slides coming up, and how these become even more important going forward. All right, so use cases. Many of you may have seen this slide or something similar to this in various 5G presentations along the way, but when we look at 5G and where it will be used, there's typically 3 use case segments that are identified, each having its own unique set of requirements, which actually Gus is going to touch on a bit later on coming up. So looking at these sort of individually or one by one, first off, there's MMTC, or Massive IoT, which is really a progression on the number of low-cost applications that are being addressed today with LPWA. So this is things like sensors, metering, smart cities, and so forth. Below that, we have EMBB, or Enhanced Mobile Broadband. And this is really what's driving a lot of the initial 5G activity that we see today. This is all about speed and making use of the larger data pipes available that 5G brings. And namely, a lot of this is surrounding millimeter wave. This tends to be a bit more consumer-oriented in its application. So we see things like fixed wireless broadband to the home, stuff that's getting deployed today. 5G smartphones, we'll see these coming out later this year. And then other use cases that are soon to emerge, things like high-end video, AR, gaming, and so forth. So all these types of applications that really are meant to take advantage of both higher data speeds, but also the lower latency that 5G will provide. And then lastly, we have Industrial IoT, or URLLC. And this is kind of a new market for cellular, something that hasn't really been addressed up to this point, and where we'll start seeing things like smart cities 2.0, smart factories, automotive applications like V2X, and so forth. So in all these, more so than speed, these types of applications really rely on the idea of getting down to close to the 1 millisecond latency performance that 5G promises, focusing more so on reliability and quality of service as opposed to just speed alone. So one of the key themes or takeaways from this slide is that you really need to know where your application lies within these use cases, and then what the corresponding timelines for those are. As an example, if you need to commercialize something, say this year in 2019, then perhaps something like LT Advanced or LTM, NB-IoTs and so forth would suffice in the interim. So expanding on that a little bit, yes, 5G is here today, but we do see it deploying in waves over time. The wave one, which really got kicked off in the second half of last year, and where we see a lot of activity today, this is really focused around the enhanced mobile broadband category, particularly with fixed wireless access deployments. And I think some of the reasons behind this are that the use case is fairly well defined, making it easier and quicker to deploy. And part of that too is that the business case around fixed wireless access is fairly clear, as opposed to some of the more complicated 5G implementations that will come later on. Wave two, and where we are this year, is where we'll really start seeing things, again based off the enhanced mobile broadband use case, but where we really see the push to bring volumes to the 5G market space, in particular with smartphones. So we'll see a lot of 5G phones being announced and coming to market later this year. And then looking into 2020 and beyond, this is really where we start to see the introduction of 5G into the IoT space. So from a Sierra Wireless perspective, it's here where the use cases that require things like 5G modules, so things like routers, gateways, PCs, and so forth, that's where all these types of applications will begin to emerge. And then beyond that, with Wave 4, what we call Wave 4 and beyond, this is where we'll hopefully see the emergence of new use cases that 5G will enable. In particular, things surrounding the industrial IoT space. So given all the hype, it's easy to feel that I might be missing the boat, or I'm late to start with 5G, but the key reality is that for IoT applications and use cases, 5G is still yet to begin. And with that, I'd like to hand it over to Gus, who will guide us through some of the technical details that are driving the evolution of 5G.
Thanks, Jim, for that good introduction on use cases and the commercialization waves of 5G. So as Jim mentioned, I'm going to get a bit more technical with you guys and talk about those technologies driving 5G, and how 5G is actually both different from 4G, and also how it's the same and why it's the same. So, but before getting into that, I wanted to make sure you guys all understand, at least at a high level, the linkage between standardization and commercialization. I feel this is important because understanding this, because I think some of the hype and confusion around 5G can be attributed to this talking about what's supported in the standard versus what has been commercialized. The Standard Development Organization, which is defining 5G, is 3GPP. I mentioned that in my introduction. But not all these features that 3GPP puts into the specification do get commercialized. Well, for example, 3GPP defined an LTE device probably 3 years ago, which in theory can support 25 gigabits per second. But this device in practice would need 8 antennas, 32 by 20 megahertz of carrier aggregation, which is obviously not commercially practical today. Today, commercial LTE devices are really supporting maximum data rates closer to a gigabit per second versus 25 gigabits per second. So you can see that there's quite a big difference, sometimes what's in the standard versus what is commercialized. Now, what gets commercialized and when? Well, it's based really on market demand and the practical technology limits of what we can do today. So this is where network operators and infrastructure vendors and device vendors sort of agree on what can be done and when. And this is why, of course, we have these commercialization waves, which Jim has just earlier presented. So also keep in mind that there's at least 1 year, but often more, between when a standard is complete and when commercial development occurs. So during my presentation, please pay close attention to, when I talk about what's in the standard versus what is or what will be commercialized. Okay, still a little bit more background. So Jim already introduced these very diverse use cases, which 5G standard was mandated to support. And unsurprisingly, these very diverse use cases translate into these very diverse set of requirements, and you can see them there. Where some of these requirements are really in polar opposition to each other. We have the LPWA requirements of really low cost, low power, high coverage, where we have the EMBB and URLCC of extremely low latencies, high reliability, high peak speed. These are not going to be cheap devices with low data rates. So there's this polar opposition, and that makes it very difficult to design one access technology that can effectively support all these use cases. So the solution that 3GPP has done is to really define 5G more as a system of components. So not define one radio access technology that can do it all, because that would be really ineffective. So we have these different 5G components that are used to satisfy these different and diverse use cases. So the 5G components include LTM, NB-IoT, and LTE, which are evolutions, of course, from 4G. And then we have NR, which is the new non-backward compatible radio standard. And we also have a new 5G core network. So those are your components. So, for example, if the 5G system is designed to support LPWA massive IoT use case, then the 5G system must deploy LTM or NB-IoT. And this is because there is no support for that use case, the massive IoT use case, in NR or LTE. But, for example, if the 5G system wanted to support EMBB, well, then it must deploy NR with LTE, which is also called the non-standalone 5G, or NR alone, also called standalone 5G. The non-standalone 5G, this is the NR with LTE, is what has been first standardized and thus unsurprisingly also first commercialized. This would have been in that first commercialization wave that Jim mentioned. Where the standalone 5G, which is more likely coming in wave 2, that'll be coming in wave 2. One of the reasons for this delay is that standalone 5G requires the deployment of this new 5G core network, and that takes more time and more effort. So lastly, if the 5G would support the ultra-reliable, low-latency use case, then you must deploy NR and also this new 5G core. So this is really going to be, we think, it's a new market, of course, and it's going to be something in that wave 4 time frame. Okay, so let's now go and talk a little bit technical. And Jim did mention that I was going to talk about this coexistence. This is one of the most interesting features, in my opinion, of 5G, is that the coexistence with the 4G, where 5G can coexist in the same spectrum. This was not possible between, say, 4G and 3G, or between 3G and 2G. And this is really important because shutting down of older generations is painful. We just went through some of this. If those people are on the call over in North America, we know the 2G shutdown in some of the operators. Customers obviously really dislike shutdowns because it means they need to deploy and integrate new equipment. But operators, really want to move to these new technologies because it gives them the best user experiences, the best performance, also often the lowest cost per bit, which is really important on that very costly licensed spectrum that they're using. So as mentioned, all the previous generations, the operators had to shut down those older generations to refarm that spectrum. With 5G, refarming 4G is not needed. The fundamental design criteria for NR was to support operating simultaneously with 4G. So this was on the day one. So this means that LTE, LTM, and NB-IoT can be operated simultaneously with NR. So this is because the base modulation of NR and LTE and LTM and NB-IoT is OFDM. And the scheduling structure as well of the 4G and 5G are the same. It's also possible because NR was designed with these advanced mechanisms to schedule around all of the 4G broadcast signals like the pilots. So the figure on the left shows an example between NR and LTE, how this can be done in this dynamic way. So the base station can decide, based on dynamic demand, millisecond by millisecond, whether to schedule LTE or NR or even both in the same 1 millisecond slot. So during initial 5G deployments, when 5G devices are rare, and demand, of course, would then be low for that, most of the spectrum would be allocated to 4G users. But in the future, when more devices are now supporting NR, of course the spectrum and demand of NR would be higher, so more of that will automatically be allocated to the NR users. So this is really a win-win for both 5G and 4G. For 5G, it expands the bands where 5G can be deployed. So this, obviously improves the time to market. The operators don't need to buy new spectrum. They can, deploy this simultaneously with 4G. For 4G, of course, it's great because it extends that 4G life cycle. This dramatically reduces the need for the operators to shut down the 4G. And for IoT applications, that have long life cycles, that increase of the 4G life cycle greatly reduces their anxiety to deploy, these 4G technologies like LTE and NB-IoT. So speaking of LPWA, what advances will 5G bring to this massive IoT LPWA use case? So the question is really asking what features are on Release 15, LTM and NB-IoT, because those are the 5G components for this use case. And remember, right, LTE and NR don't support this use case. So in short, 5G brings more capacity and better battery life. The more capacity was added really to meet the 5G requirement of 1 million devices per square kilometer. And the improved battery life was added actually mainly to address market demand, but there was also some need to more exceed some of the 5G current requirements, battery life requirements that were set. I'm not going to go into these in detail. I just don't have the time here. But if you do, if you're curious about any one of these features, feel free to ask a question in the Q&A. So what's really important here, though, also is that these 5G LPWA features will be possible with a firmware upgrade. So many of the NB-IoT and LTM modules that we're shipping today can be upgraded so they're future compatible, or you could say 5G ready. So keep in mind this slide I'm presenting here is the list of features in the standard. What will be commercial could be different. But our view, at least at this time, is that most of these features are actually quite useful and thus should be commercialized. Okay, so moving on to the Release 15 LTE standard. So here's the major features in the Release 15 standard, which was frozen June of last year. The first feature is the LTE-NR dual connectivity feature, more technically known as ENDC. This is a mandatory feature for any deployment that is non-standalone 5G deployments that I mentioned earlier. And this is mandatory because this is how the NR traffic gets scheduled from the LTE system. So this feature has already been commercialized today in release in the Wave 1 that Jim had. The new ultra-low latency feature, which is new in Release 15, is designed to significantly reduce the latency, unsurprisingly, and it's very significant. The latency can go down to about 1 millisecond from today, theoretically, is about 15. So this is actually enough to meet the 5G latency requirement of sub 1 millisecond. However, this feature does require significant changes to LTE, very low-level changes, and so the commercialization at this point is a bit questionable, which is why I put it in gray there. Moving on to the new ultra-high reliability feature. So this is about improving reliability so that 99.99% reliability can be achieved, and so this is the 5G requirement. And so again, this feature allows LTE to meet that 5G requirement. However, similar to the ultra-low latency feature, this feature requires that significant low-level changes, and so we also feel the commercialization of this is questionable. So there's also some evolutionary changes in Release 15. Of course, we always have to increase the speed, so the specification now supports up to 32 gigabits per second, which definitely exceeds the 5G requirement of 20 gigabits per second. But similarly, what I talked about before with the 25 gigabit device, this is unlikely to ever be commercialized. However, we do expect some improvement, in speed for products that will support with the Release 15 LTE. So the peak speeds we see coming will be, sort of above 2 gigabits per second. And this is really important because, what we know is that, NR is not going to be deployed ubiquitously. And so having a consistent user experience when, users fall back to LTE is a good thing. So the other evolutions of the vehicle to everything and license assisted access and carrier aggregation, are basically in there to improve latency, user experience, and more spectral efficiency. And the commercialization of these will also occur, but will be several years away. Okay, so now moving on to NR, the new stuff. So here is the list of the major features in the first release of NR, which was Release 15. So this was frozen June of last year. So NR, of course, is that new non-backward compatible 5G component. So the big news here is that NR supports millimeter wave. And millimeter wave is basically that really high spectrum, 20 gigahertz to 300 gigahertz. So this is really big. I mean, this is the first time ever millimeter wave has been used in a cellular system. And there's a good reason why it's taken, this long to use this, and because it's hard. There's a lot of technical stuff that had to be added into the standard of this, and there's a lot of deployment challenges, and Jim will, I think, touch a bit on those as well. But it also, has some cool technologies like I mentioned, so I'll talk about those a little bit later. So the NR specifications support some crazy high peak rates, actually up to 215 gigabits per second, as a theoretical maximum millimeter wave. But of course, this is again not going to be something that will be commercialized. The first wave of commercialization, we expect to see peak rates more in the 5 to 7 gigabits per second. So still pretty impressive though. So NR, like LTE, also supports the ultra-low latency feature, but can even go much lower in theory. Can go actually to 0.1 millisecond in theory. But as was mentioned, this would be for this URLCC use case, which is a fair ways from commercialization into that wave 4 kind of time frame. So, however, the latency, as Jim mentioned, is going to be improved for NR. So for the eMBB use case, we will see some significant latency reductions. We figure down to between 3 and 5 milliseconds from the theoretical 15 that we see in LTE today. The NR ultra high reliability feature can, similar to LTE, provide those 5 nines of reliability. But again, commercialization of this is into wave 4, we figure. So as you can see, though, Release 15 of NR has a lot less features than LTE, and this is because Release 15 is just the first release of NR, and there just simply wasn't enough time to add kind of the bells and whistles on top of the base that was done. So the next release of NR, which is called Release 16, is well underway in 3GPP, and we'll be adding a lot more features, which I'm going to talk about a little bit later. So moving on to what cool things are in Release 15, though. So this is probably the most techie slide that I have. So as you can see, though, here on the right, I've kind of highlighted beside each of those cool technologies the reason why we need them, and you can see that millimeter wave and the low latency requirements are really driving some of what I call the cool technologies here. So the first one I'm going to talk about is the flexible subcarrier spacing, sometimes more technically called flexible numerology. It's arguably the most important difference between LTE and NR. So LTE has this fixed subcarrier spacing, and this is for the OFDM modulation, where NR now supports a variable subcarrier spacing between 15 and 240 kilohertz. The higher the subcarrier spacing, these are absolutely mandatory if we want to support, that high spectrum, especially the millimeter wave. This is why LTE simply can never run in millimeter wave spectrum. The main reason why we need this higher subcarrier spacing is because the phase noise that's in the radio is proportional to the operating frequency. And when the phase noise gets close to the subcarrier spacing, the orthogonality between the subcarriers is degraded. So simply put, you lose the O in OFDM, so it doesn't work anymore. So beamforming allows the RF energy to become more focused in a direction. LTE supports beamforming too, but LTE only supports beamforming in the user plane channels. So this is the user data, which is great. It helps the data speeds of that, and it also helps spectral efficiency, but doesn't help with coverage because, of course, the other control channels now become the limiting factor. So with the coverage challenges associated with millimeter wave, it was really important that NR actually support beamforming for all the channels so that coverage could be expanded. So NR does support the broadcasted and random access channels as well. Wider channels, so really needed in NR because millimeter waves are the channels that we can have there or can be very, very large, gigahertz or even more. LTE has a maximum channel bandwidth of only 20 megahertz, so you can imagine it takes many, many, many 20 megahertz to get to your 1 gigahertz. So in NR, they've increased that channel support to 400 megahertz. Faster TDD. So TDD is really important for NR because a lot of the new frequencies, the higher frequencies, are TDD. They're not FDD. LTE TDD, though, can only switch between the uplink and downlink every 5 milliseconds. So, of course, trying to hit latencies of 1 millisecond is now impossible if you're only switching every 5. So the NR TDD can switch much faster. It can switch on a symbol basis within a slot. So, and there's multiple slots within a subframe. So you're really getting switching, at a fraction of a millisecond now. So preemptive scheduling, this basically allows higher priority transmissions to interrupt lower priority transmissions, even if the transmission is already started. With LTE, you have like a QoS where you can control what transmissions you want to start, so you can prioritize. But once they're started, they have to complete. With NR, we can actually even basically preempt a transmission that's in progress. And the last one I wanted to mention was the short and minimum scheduling unit. The latency is roughly proportional to the scheduling unit time. So the shortest scheduling unit in NR was reduced by a factor of 100 compared to that of commercialized LTE today. All right, so moving on to the future. So release 16. So as I mentioned, 3GPP has already started work on this next release of NR called release 16. And this is set to freeze in March 2020. So keep in mind though, right, we're going to have at least a year between that and commercialization. So commercialization is like 2022. There's a lot of things that are happening here. So I only pulled out actually what I thought were the major ones, but listed below there's a whole lot of other, what I would call less major. But if you want me to talk about those, please, you can ask questions about those in the Q&A section. So the first major feature I have is the unlicensed spectrum. So this will support what they call LAA, which is a licensed assisted access support. So some of you may know what that is. This is where your operator has licensed spectrum and you're using that to assist scheduling traffic in an unlicensed band. But what's more interesting is that the NR will support the standalone private networking in unlicensed band. And so this is the first time ever 3GPP has ever specified support for standalone or what they call private networking in an unlicensed scenario. So this really helps expand the market of NR. Enhanced V2X, so this feature builds on basically what LTE does with the vehicle to everything support, adding support for millimeter wave as well as the ultra low latency for self-driving cars. Integrated access backhaul is also a pretty cool feature. So today, base stations basically need to be hardwired backhauled or some other wireless access technology backhauled, which is expensive. This new feature of integrated access backhaul allows a single radio, so a single NR radio, to service both the cellular customs as well as be used for backhaul simultaneously. and dynamically trade off capacity between the two, the backhaul and the cellular users. So this, of course, now makes it much easier and cheaper to deploy small cells, which, of course, is typical in millimeter waves. Satellite networks. So this is the goal of this feature is to make changes to NR such that it can be used for satellite communications. This feature is still a little bit in its early stages. It's sort of in what they call steady phase, so it's a little bit uncertain whether this will be in Release 16 and what kind of changes will be needed here. So power consumption improvements. So there'll be several new improvements added in Release 16, and basically in the first release of the specification it was quite rushed, so a lot of these power consumption optimizations were deprioritized, so we're adding these back in Release 16. Similar story for the enhanced industrial IoT. The first release was a bit rushed, especially on the reliability methods. So we had some very simplistic methods for improving reliability, and Release 16 will include some techniques to improve that. And then lastly, location positioning and tracking. Of course, in Release 15, you can do non-network-based location GPS, but there was no network-based location support in Release 15. So this will be added to Release 16. So that's what I had. Hopefully you learned something there, and I'm going to now pass it back to Jim. Thanks.
All right, thanks, Gus. I'd just like to spend a few minutes sort of summarizing some of the key points and touch on a few things. First, just the topic of millimeter wave. As Gus mentioned earlier, for cellular or wireless WAN, it is one of the key technologies that 5G brings. And for many, when they think of 5G and the multi-gigabit speeds that it's going to bring, it really is millimeter wave that they're thinking about. That said, I do want to point out that millimeter wave will add some complexities and cost to any platform development or integration effort. There'll be a lot of characterization work, calibration that's very platform specific that needs to be done. So this will be, costly and time consuming, but if your application demands that, then it'll be well worth it. Do want to point out though that millimeter wave rollouts around the world will take some time. In fact, not every carrier or country is deploying millimeter wave from the get-go. There'll be many phased approaches to this, and so we do see a large market for 5G LTE or sub-6 NR applications in the early stages. So we definitely encourage you to evaluate the need for millimeter wave. There are certainly a lot of benefits that millimeter wave will bring, of course, particularly when it comes to speed, but it may or may not be required for your specific application. I mean, either way, Sierra Wireless is going to be here to support you. And at Sierra Wireless, we are going to be investing heavily into this millimeter wave technology. We want to be ready for all the options. So whether you require millimeter wave or whether you just need 5G LTE or sub-6 only, both are considered 5G, and we can help you guide you through that decision process. So then, just to revisit these three use cases for 5G, I think it's important to determine, again, where your application fits within these sort of large buckets. For those looking at industrial IoT type applications, you definitely have time. We don't see deployments happening here really until 2021 and beyond. So, there's definitely time to take stock of where you are and how you want to get to 5G. With MMTC or the massive IoT, this can largely be addressed through LPWA today and can be software upgradable to 5G later. So you're future-proof from that point of view, and there's nothing preventing you from getting started today and deploying with LPWA or NB-IoT. And as for enhanced mobile broadband type applications, here's where there's a lot of activity today. So, now is really the time to start thinking about your 5G strategy. And then to recap on the wave slide, again, just to recall, there are different waves of, or will be different waves of 5G rollouts. Wave 1 started last year. We'll see Wave 2 this year coming with smartphones and more consumer type applications. But for the IoT space, kind of the key theme for this discussion today, depending on where you are, there's still time. So you haven't missed the boat per se when we look into Wave 3 and beyond. Lastly, I just wanted to impart that Sierra Wireless is well positioned to manage your transition to 5G, no matter which path or how that looks. As highlighted on the graph here on the right, Sierra has a long history of being first to new technologies, and we want to continue that tradition into the 5G IoT space. Sierra operates around the world today. We hold leading positions in a number of segments with LTE, like smart metering, energy, networking, PCOEM, automotive, and the list goes on. And the good news is, we see all these transitioning to 5G over time. So we're getting geared up and we're getting ready. So whether you're on LTE Advanced Pro today or LPWA or NB-IoT, we have a path to transitioning to 5G when and where you need to get there. And with that, I'd like to
hand it off to me, I presume. This is Ken coming back. Thanks, guys, Gus and Jim. That was really enlightening and awesome. And judging by the number of questions we've had come through here on the Q&A, our audience is pretty engaged here as well. Folks out there listening, just want to remind you and let you know that you can still submit your questions. Down at the bottom of your screen, you'll see a Q&A button. Go ahead and type in your question and send it in, and we'll get to as many as we can here. Looks like we're going to start with you, Gus. Our questioner here is asking you to describe licensed versus unlicensed spectrum and how one is different from the other and what some of the different benefits are.
Sure, Ken. That's a good question. Of course, the licensed spectrum is probably what you see and hear all about these auctions from, for example, FCC, where people are paying really a lot of money for the spectrum. I think we just went through a millimeter wave spectrum auction more recently. So, license doesn't mean no sub-gig. Keep that in mind, right? You can get licensed millimeter wave. And so the unlicensed, of course, is something that you don't need to operate on. Of course, the most popular, of course, is the ones that the Wi-Fi, Bluetooth run, the 2.4 and 5 gig. But there's also some unlicensed spectrum coming in millimeter wave. So that's what those are. Now, the benefits. The unlicensed spectrum. Of course, the benefit is, well, it's free, right? People can use it within the rules that the regulator body has set up. Often those rules can be a little bit difficult, like, for example, transmission times. Especially in the 900 meg band, you can sometimes only transmit 1% of the time. So you can't often utilize the spectrum in the same way. Also, the coordination and the spectral efficiency that you get in those unlicensed bands is often quite poor because collisions, there's no coordination. So those are kind of the disadvantages here. It's not clean. The thing too about the unlicensed band too is that for small deployments they need local coverage. For example, a campus or something like that. Somebody like Wi-Fi can easily deploy a few access points, and the cost to operate that network and the knowledge base to operate that network is quite low. So that makes sense. But for, of course, macro networks, when you want to cover very large areas, this is where the private networking side really doesn't make a lot of sense. Now, I think I mentioned earlier that NR is moving into this kind of private networking space, so I think it's quite interesting. I mean, it's this expansion of that market. For people that do want to maybe deploy a local NR system, this is going to be something that's going to be possible in Release 16, which I think is really exciting.
I think so too. I think that's really cool. Let's see what our next question is. Thank you, Gus. Oh, Gus, you're up again. Will LPWA, low power wide area support, ever be a 5G NR technology?
Wow, that's a really good question. It's kind of a little loaded, I think. Maybe I want to make sure that I'm answering the right question. So remember that, of course, LPWA use case, I mentioned this a few times in my presentation, is only supported by NB-IoT and LTM, right? LTE and NR doesn't support, and it doesn't support this LPWA use cases. And also, I presented in Release 16, right, the second release of NR, also doesn't support this LPWA use case. So we have no support at all, right, for this use case in NR. So this is what the question is getting at. It's really asking, what will happen, sort of beyond Release 16? Release 16 is closed. There's definitely, that's not going to be added. So the question is kind of like, well, what's going to happen, after, Release 16 and maybe Release 17? So the short answer is maybe. But if it does happen, it will be quite a bit of time from now. So the Release 17 planning is going to happen in December. This is a really large feature, so it's probably going to be what they call a study phase, which means that the normative specification work, the best case would be in Release 18. So you're talking about commercialization 2025, at the earliest, if we do it. And it really, if we do it or not, is really quite questionable. But I believe that if we do something like that, it'll be differentiated. Like, it'll be slightly different. It'll cover different use cases than what we see, with LTE and NB-IoT. So maybe slightly higher functioning, higher speeds, which of course the trade-off means it'll be higher cost, lower power require more power, and maybe even some less coverage. So that's kind of what we feel.
Sure. As with any good question, the answer is always gray area.
Yeah, exactly. Great. But that's right. So I gave some color. Hopefully that helps add, I can't, of course, explicitly predict the future. If I could,
sure.
I'd be rich.
In a different line of work. All right. So, and Jim, don't worry. There's some love for you here in the Q&A. I've got a question for you coming up next. Jim, our asker here wants to know how many new antennas will be needed for the new millimeter wave.
Yeah, that's an interesting question, and part of what I alluded to in my millimeter wave slide. There's no, I think, definitive answer to this, and it's really going to be application dependent. And that's part of the, as I call it, the characterization that needs to happen when you go through a development. As an indication, I think, phones coming out with millimeter wave will have 4 antennas, and they're directional, right? So sort of one for each direction that allows for handoff depending on, how your device is oriented. So no simple answer to that, but depends on the use case, the application, and where and how it'll be deployed.
Yeah.
More
we've got another millimeter wave question here. So it's specifically directed toward you, Gus, but since you're already on the roll here, Jim, maybe you both want to comment on this. What are some of the distance limitations of millimeter wave and some possible means to address those distance limitations? Why don't we start with you, Gus, and then Jim, if you've got anything to add, you can jump right on.
Sure. Yeah. It's definitely a debated topic. You hear numbers like 200 meters, but then other people talk about 500 meters. But of course, this all depends on a lot of things. mostly what speed you're talking about. If you want to hit that 5 and 6 gigabits per second, you're not going to be doing that at 500 meters. But if you want, something, slightly around the gigabits per second, you can go farther. So that's one thing to keep in mind, that, range depends on the user experience that you want to provide. And then, the range also depends highly on the environment. When you're actually in sort of more really urban downtown areas, the range can often actually be better because millimeter waves bounce off nicely cement and concrete and stuff like that and don't get absorbed. Where in more suburban or definitely rural areas where you have foliage, it's horrible. Like it just sucks up all that energy and doesn't let it out, and so you're going to go a lot less far. So this is why we really think that millimeter waves, that kind of deployment is really designed more for those urban centers, and I don't think we're going to see them in the macro centers. And now the means to address them, well, I think those are some of those technologies I mentioned. Beamforming is probably the biggest one, right? Basically, like all link budget, it's about getting more energy to the device. And beamforming is one of the best ways to do that. So especially if the application is fixed, like the fixed wireless access where the device is not moving, and beamforming becomes a lot more practical. And it's very effective. And I guess that's probably the number one reason.
Is it practical? This is sort of a follow-up there. Is on this range discussion and everything else, is it practical to install base locations every, say, 200 meters? And does that make sense to do if you're trying to deploy throughout an urban area? Should you just build this grid?
Well, yeah. People are doing it, so I think it's practical. It depends on the population density, the business case, the use cases that you want to do. Also keep in mind, when you're talking about going to say 500 meters, well, a lot of the really urban centers of downtown already have base stations deployed, even at 4G at that level. So it's not. It sounds like a huge stretch, but definitely in urban areas, it's not. And as I mentioned, this integrated access backhaul is just going to make it that much easier where, literally they can, on a light pole or whatever, now just put a base station. And so that's going to really, improve the ease at which these things get deployed. But as I mentioned, for rural areas, this just won't make sense, right? The business case, right, I think, won't make sense there.
Jim, this one's for you. Given that NR can be deployed in millimeter wave and conventional cellular bands, would you expect single products to support both types of connectivity? Will that add cost? How do you think that sort of function is going to work out moving forward?
Yeah, good question. And what I will say from our perspective and what our design goals from Sierra Wireless's point of view is we're looking to ensure that we provide the capability and the option for both. So whether you want to support millimeter wave and sub-6 and LTE and other fallback, or not use millimeter wave, our proposed product that we're working on now will have the ability to support either path. Now that said, the question about costs, yes, support for millimeter wave does add both hardware costs and then probably some additional development and integration costs. So that's something we need to be cognizant of.
Awesome. Folks, just a quick reminder that we do still have time for one or two more questions here in the Q&A. So if you want to get one in under the wire, go down to the bottom of the screen, hit that Q&A button, and send in your question, and hopefully we'll have a chance to get to it. Also, I wanted to let everyone know who's listening as we get near the end here that the presentation is being recorded, and there will be an archive. You'll receive an email with directions on how to view that after the fact. So you'll be able to check this out again and refer back to it, as I'm sure you will be. Gus, our next question is for you. And let's see here. It's asking REL 15 of LTEM and NB-IoT is considered 5G. So what specifically would need to be implemented to call something 5G is the question.
Yeah, okay. So, well, I mean, what people are calling things is certainly, again, a gray area. I think we've seen some news with respect to the naming of 5G. What people consider here. But well, technically speaking, again, this is my view, is that at a bare minimum, you need to implement at least one of the Release 15 features. Because, of course, Release 15 is the first version of LTM and NB-IoT that is one of those 5G components. So I think at a bare minimum, you need at least one. But remember, there was over 10, well, it was more than 10 major features that are defined in Release 15 for NB-IoT and LTM. So I'd actually hope that vendors implement a lot more than one, and so that there's kind of more measurable improvement, in battery life, capacity or coverage, so that that label becomes more than just some kind of marketing tool.
Yeah, I would agree. I think that that some agreed upon definitions would behoove us all in this area. We've got a new question. I think this one might be right in your wheelhouse, Jim. But of course, you're both welcome to swing at it. This question is related to LPWA, massive IoT, MMTC, NB-IoT network deployments. And our asker is wondering whether or not the telcos are upgrading their core networks with SCEF elements to handle non-IP message delivery. So we're getting deep into the weeds now. These questioners want to know everything.
So so the SCEF, as we call it, that's the Service Capability Enablement Function. So yeah, this is definitely a very technical question. Let me see. The reason it's difficult for me to answer this is because, of course, this is what a network operator would do, and information that we have on the deployments that network operators do is somewhat sensitive. But let me see how I can answer this. I think that a SCEF, with this non-IP delivery is a really good feature, and I think we might see it in the near future, the very near future. Let me put it that way. Let me answer it like that.
Yeah. I think that works, and seeing things in the very near future is, I think, a really great way for us to start wrapping up here as we're getting near the end of time. Let's just take a quick look here. Yeah, so I would like to thank Gus Voss, Chief Engineer, Technology Standard at Sierra Wireless, and Jim Engelson, Senior Director, Product Management of Sierra Wireless. And of course, thanks Sierra Wireless for sponsoring this really informative, excellent webinar. This was really great. I'd like to thank all you folks out there who are listening and taking part and asking your questions. We are sorry if we didn't get to your question today, but I assure you that Gus and Jim will be poring over them endlessly over the next couple of weeks, and we'll be reviewing them and getting back to as many of you as they can. As I said, you'll be receiving an email with instructions on how to view the archive of this presentation if you would like to review it, and I'm sure you will. I have been Ken Briota, your host, and I'm here with IoT Evolution, and I'd like to thank you for taking part and listening to today's webinar, 5G for IoT, Beyond the Hype. Thank you very much, and have a great day.